Yeah, so in this third and last video of lecture 3, I'm going to show you how to run Python code, running Python code. And by that, I don't mean to introduce you to all the concepts of Python, but rather I will talk about the different ways we can execute Python code. Most importantly, I will talk about Jupyter Notebook, which is a certain file format and also program for Python code that you will be using for the homework. The first homework assignment will be sent out next week. I'm currently preparing that, and it will be likely about implementing a k-nearest neighbor classifier. And to make the homework most convenient so that you can write text, have some equations, run code, and also have plots in one document, I will ask you to do that in a Jupyter Notebook, and I will show you in this video how to set it up if you have not worked with Jupyter Notebooks yet. But for now, let's take this step by step. I will show you first the easiest way to run Python code. So I would say the easiest way is using the interpreter, or some people also call it the REPL. So interpreter or REPL. So yeah, REPL is a weird name. It stands for read, eval, print loop. And that simply means that we are executing Python interactively. And we can do that, for example, if we go to our terminal. Let me do this a little bit larger here. By opening Python, and then we can go ahead and execute our code. Yeah, the reason why we call it interactive is that it gets evaluated immediately. So that means if I write down an expression in my interpreter and I hit enter, we can see the results immediately. So let me show you what I mean. So if I type print, let's say 1 plus 2, it will already show me the result immediately. I don't have to compile anything or run a script or so forth. And this is what I mentioned also in the first video. And the same goes also for more complicated things, let's say a for loop. So for example, if I loop over the values 0 to 5, oops, I forgot an in for in range indentation. So if we print the values 0 to 5, they get printed immediately as soon as I finish my for loop. So the dots here, these are line continuation characters. So that just means that the line or the command ends here, and then after I press enter here, it will execute my code here. Yeah, in practice, we rarely need to do that kind of interactive computing. So personally, I would maybe do that sometimes if I have to quickly compute a sum. So I, in a way, use Python sometimes as my calculator. For example, if I want to know the sum of some numbers, I would just type 1, 2, 3, 4, something like that. So I would just use it for my convenience. Instead of using a pocket calculator, I go to my Python interactive interpreter, and that's how I execute code. But personally, I would never use the interpreter for more complicated code because it's easy to lose sight of what computation we are doing if we make, for example, some typos, and you see then that we have some error messages in between, and even if we fix them, they're still there. And then sometimes if we want to read what we have done like 10 minutes ago, for example, it becomes tedious to scroll back and find the commands that we executed. So personally, when I write more complicated code, I would do that either in a Python script or in a Jupyter Notebook. And I will also show you when to use which and how they work, the Jupyter Notebooks. But before we get to that, let me show you an alternative interactive Python interpreter. It's called IPython. So let me quit this one. So I think if I type IPython here, it will not work because remember, last video I just installed Miniconda and I didn't install anything except mlextend, numpy, and so forth. So let me try that. No, it doesn't work. So IPython is an interactive interpreter that I really like. And Jupyter Notebooks, for example, they were back in the day called IPython notebooks because they were built on top of IPython. So and still, Jupyter Notebooks, as far as I know, rely on IPython, which is a very nice alternative interpreter that has some additional features. and especially the so-called magic functions. But let me go ahead and install IPython so that I can show it to you. And by the way, if you want to visit the IPython website, you can go, I think it should be ipython.org. Oops, let me see if that works. Yeah, so the IPython website is here. If you want to learn more about IPython, they have also documentation here and so forth. See, a lot of that is also mentioning Jupyter. Anyways, let's install IPython. Because I prefer Conda, I use Conda for installing IPython. So Conda install IPython. Now, after installing IPython, we should be able to start it from the command line. Yes, that worked. And you can already see it's a little bit more colorful, right? So if I do the same thing I did before, you can see it has nice syntax color, which is relatively nice and helpful for writing some more complicated code. So let's just do the same thing we did before. For I in range 5, you can see it looks a little bit nicer. It's also nice it has this history function, so you can go back and edit it, which the normal interpreter doesn't allow you. So it's more easy to modify some code. We can, for example, just go in here and add one without having to rerun everything or retype everything and so forth. So in that way, already the editing or modifying code in IPython is easier than using the regular IPython interpreter. So one killer feature of IPython, I would say, is the question mark symbol. So in Python, we can get help by using the help function. So I can type help sum, which is nice. But yeah, the IPython interpreter has a nicer, shorter way. You can just type sum question mark, and it gives you this, I think, more readable version of this. It's especially useful if we have more complicated documentation strings. This is maybe a very simple one, but I really like that. And with that, so there's not only the question mark, but a whole bunch of useful features. And these features are called magic commands. These usually start with this %sign. I will only show you one particular one for now, and that's the time it magic command. I really like that one because it helps you to very efficiently and quickly compare different code implementation to see which one is more efficient. To show you what I mean, let me implement two functions for reversing strings, and then we'll take a look which one is faster. So function 1, let's call that reverse string 1, because I'm not very creative, just my string here. And for this function, I will just use the join function or method together with reversed my string. That's one way for reversing a string. And the second way, the second function, I will call that reverse string 2. And for this one, I will be using just indexing. I will talk more about indexing next lecture when we talk about NumPy. But yeah, so these two colons mean basically, so the first colon is the beginning and end. So if we don't specify in the beginning and end, it will take the first and the last position, and the -1 will flip it around. So it will start at the end and go to the beginning. So we will reverse the string this way. So just to make sure that this actually works, let us test our function with just some arbitrary string, hello world, reverse string 1. That works, right? If we read it from here to here, it's successfully reversed. Let's try our other function. All right, same results, that's great. Now we can use the timeIt function to find out which one is more efficient. This seems a little bit silly because it's a very simple function here and we're just reversing a string, but for real world application, when you implement code, like scientific code from scientific computing, it sometimes really matters how efficient your implementation is, and then it becomes really useful to compare different functions. So I can call timeIt and then the name of my string function or reverse string function. And then also with an argument, let's just use a. And when I execute it, it will do a benchmark. So you can see it runs in 370 nanoseconds plus minus 10 nanoseconds per loop. So it's running 1 million loops. So it's executing the function 1 million times to get a good idea of how efficient it is, and it repeats that 7 times and then computes the average. So each run consists of 1 million repetitions, and then after doing that 7 times, this is the mean plus minus the standard deviation. You can actually control the number of runs and loops by, I think the argument is minus n for the number of loops, and the other one is minus r for the number of runs. I have to double check. By default, it may vary based on your function, so they do some automatic guessing of how many times to run it so that it runs in a reasonable time. So we are just using the default arguments here. Let's do that now for function number 2. All right. Yeah, we can see the second function is 3 times faster approximately. You can see it's now 130 nanoseconds. It's like 1/3 of the time. Of course, we are only doing that for a very short string. We can also do that for a super long string. So maybe just for fun, let's do it. Let's just do something arbitrary here and repeat our string maybe 1,000 times. Let's do 10,000. So we'll have this very, very large string, and then we do the same thing again. Okay, again, it's just, I should have used B here, sorry. All right, that makes more sense. So it's now 1.33 milliseconds. Before it was 371 nanoseconds. Of course, it's way slower because our string is way longer here. And also you can see it only runs 1,000 loops for now because otherwise it would take too long, and it's doing some automatic guessing that we don't have to wait forever. Let's do that for the second string or second string function. Yeah, so based on these results now, we can see that the second function is magnitudes faster because it's now about 30 microseconds. And here we had 1.33 milliseconds, which is 1,330 microseconds. So 1,300 versus 30, it's approximately 40 times faster running the second function. I mean, the point was not really which function is faster, but yeah, we learned about this nice timeIt function and why IPython notebook, IPython, the interpreter, is very nice and has some extra benefits that the normal Python REPL doesn't have. Yeah, the second way we can execute code is using Python scripts. That's what I showed you already in the first video. So we can make a file. Let's save that on my desktop, call it my script.py, and then we can write some code for I in range 5, print I. And then I go to my terminal and execute that. So that's the second way that we can use to run Python code. I just see it says linter flake A is not installed. I think this is just due to the fact that I just uninstalled Python yesterday, right? If you remember. So let's install that using conda. And a linter in Visual Studio Code is really nice for making sure that your code has a good style. For example, if I write some function with some function argument, let's do it like this, and it just prints out the value of A. Nothing really special here. What it will do is it will highlight issues like style issues. It's like with the English language, if you have a comma mistake, it's kind of not terrible. People can still read your text, but it doesn't look so nice if you have like spelling errors and stuff like that. And the same is true for Python code. So there are certain guidelines. They are actually explained in a document called PEP 8. And linter, the flake 8 linter, helps you with writing cleaner code. For example, I can hover over here and it says that there are some issues. For example, no new line at the end of the file. So if I do a new line, then this will be resolved. Undefined name A. So yeah, so it's also not only helping us with typing errors, it's also helping us with basic code problems, because we haven't defined A, so we should have written some string here, right? Because A is an undefined variable. And here, what's the problem? Expected 2 blank lines after class or function, so we have to add another line here, and then this is much nicer. This is the more professional way to write Python code. And it will also highlight, for example, issues if I put a white space here, it will say unexpected spaces around keyword. It's the code will still run, but it's just good style to do it like that. So by the way, also with the spacing, for example, if I have a variable and I do it like this, here the white space is expected. So here the white space is expected. If I would remove it, likewise, it would complain missing white space, because here it's a mathematical operation. So we have a white space also for the variable assignment. So usually for variable assignment, we use a white space. However, inside a function, when we define the parameters, also if we provide a function argument for a parameter, we don't use white spaces. It's just a Python convention. But yeah, if you're not familiar and you have a flake 8 here installed, it will complain about it if it's not working, and which I think is a nice feature also of Visual Studio Code. Yeah, so the last tool I want to show you is Jupyter Notebook and Jupyter Lab. Actually, I'm only going to show you Jupyter Lab. So Jupyter Lab is a program that runs Jupyter Notebooks. So there are Jupyter Notebooks, which is a file format, and the files are abbreviated IPython. That's just a convention in Python that comes from the fact that they were back in the day called IPython notebooks. And it's a little bit confusing, but there's also a program called Jupyter Notebook. So Jupyter Notebooks can be opened in an application. So this is an application, and this is a file. The file can be opened in the Jupyter Notebook application, but it can also be opened in the Jupyter Lab application. And Jupyter Lab is just a little bit newer than Jupyter Notebook. It's newer than this one, and it looks a little bit nicer and has some more convenience features, which is why nowadays I recommend using Jupyter Lab instead of the previous Jupyter Notebook. And I will show you how we can do that. So for that, let's go to the terminal. Once you have Jupyter Notebook installed, you should be able to call it via Jupyter Lab. However, remember I just installed my miniconda from scratch, so it should not work right now. Yep, it's complaining. So we would have to install it first. So let's go to the Jupyter Lab website. It should be on jupyterlab.readthedocs.io, I think. So let's try that one. Yep. And here I would just look for the installation here, and usually they recommend, they use conda forge still. So let's copy that command here. So you can also install it via pip if you like. But yeah, since I'm using conda, I will install it using conda. Yeah, so now after installing it, we can open it from the terminal, Jupyter Lab, and it will open in our default browser by default. So yeah, it will make a new browser view here, and here on the left hand side we have a navigation that is just our file system. So I go to desktop and I can make a new notebook by just clicking on notebook here. And it's currently called Untitled. You can see it was just created here on the right. Can rename that, and let's call that just my notebook. And yeah, this notebook is something really cool because you can write Markdown here, you can execute code, you can have plots here. What else? You can have LaTeX in here. So let me just maybe show you something to begin with. So I can, for example, choose Markdown. And Markdown is if you have not heard about it, maybe search for it on the web. It's a very easy to learn language, which has some convenience functions. For example, I can type header 1, header 2, header 3, and then some text. So this will be converted to a header, which is bigger than a regular text, for example. And this is the biggest header, the second biggest header, the third biggest header, and so forth. And you can also have some quote text. So I should also make it Markdown then. Or I can modify it here, it's maybe easier. I can have italics, or bold font. Can have links very easily. For example, Jupyter Lab website. I can create links for other people to follow links like that. Lots of nice, easy things to format a text in Markdown. And what's also nice is allowing us to have equations, LaTeX equations here. For example, if I write something, I don't know, what should I write? Maybe the weighted sum z. Let's call it sum I over n. Or maybe just something simple. Something like this. So you can see it's formatted as LaTeX equation here, which is also very nice. So if you write some code and you want to explain certain things using mathematics, you can just also have directly the LaTeX in here, which is sometimes very convenient for note taking. Yeah, another thing you can do is you can have plots here. So for that, I think I have not installed matplotlib yet. So another thing is about Jupyter Lab or Jupyter Notebook is that you can use the exclamation mark to execute terminal commands. So instead of going to my terminal and running conda install matplotlib, I can do that directly here using that exclamation mark. So you will see if I don't use it, there will be an error, right? Oh, it's actually working. Okay, I don't even need to do that. Usually there was an exclamation mark required for that. So what does it say here? Oh, I actually made a typo. I should have written matplotlib. Yeah, it's a little bit hard for me to type here when I have my desk at an unusual height to make the microphone work. So I have to maybe find a better solution so that I can type better here and not make so many typos. Okay, let's see what it did. All right, it installed matplotlib. So let's restart the session because it recommends us to do that. We don't need this one anymore. So now there's also a certain way for Jupyter Lab to have plots in line. So usually what we do is matplotlib inline, then plots will be shown in the notebook. There are some different options like a Matplotlib notebook and so forth, but usually this is the one that works on most computers. And then, for example, we can import matplotlib.pyplot.splt. It's also import NumPy. We will discuss what that is in the next lecture, in lecture 4. I just want to briefly show you how nice it is to show plots in the Jupyter Lab here. Okay, let's just use some values. Or maybe let's just some random values. And then we can plot a histogram. Yeah, and you can see everything is nice in the browser here, so I can then also annotate it and so forth. So yeah, I really like that. It's having everything in one notebook. So of course, this is a very trivial example here, just some random stuff. However, when you work on real code later, it's sometimes very helpful to visualize your results. And using Jupyter Lab, it's very nice to have code, notes, plots, everything in one place. So the last question for today might be, when should you use Jupyter Lab and when should you write scripts? So that's a tricky question. Personally, I use Visual Studio Code, so Python scripts to develop functions or code in Python. That is, let's say, code of a package or code that I'm planning to reuse. And I use Jupyter Lab, just like a notebook to do some analysis or to take notes and to explore and stuff like that. But I also find it super helpful for writing documentation. Maybe to show you what I mean by that, let me give you a concrete example. So I mentioned before that I'm working on this MLExtend library for Python. So for MLExtend, I have, for example, my code repository. This is just a Python package, and then I have the code here, for example. So let me open a file. This is an implementation of an ensemble vote classifier, and we'll talk more about this later in this course. And this is just the implementation of this classifier. So there's a lot of code, and this is something I would write in Visual Studio Code, right? But then if I use the ensemble vote classifier for some analysis, then what I would do is I would use a Jupyter Lab environment or Jupyter Notebook. So for example, in this context, I have documentation here. So if I go to docs, sources, is a little bit complicated how I set it up, but yeah, I write my documentation in Jupyter Notebook or Jupyter Lab. So for the classifier, ensemble vote classifier, I would have this file here, this IPython notebook file. So you may be wondering what's going on with the MD files. It's a markdown file. You don't have to do that. I'm just doing that, converting the Jupyter notebooks to markdown because I have a website for MLExtend. So for example, here on this website, I have an HTML version of the markdown. So basically the IPython notebook gets converted to markdown and the markdown gets converted to HTML, and that's what you see here. But oops, there's a lot of warnings going on. I should maybe improve that in future. So but here there's just some documentation for how to use the method. So you can see I'm using some LaTeX here. By the way, there's some weird issue in Safari that it doesn't really show LaTeX nice right now. You could open it in Firefox to make it look nicer, but that's kind of right now not necessary. And yeah, so I have some LaTeX here, some explanations. Then I have my code examples and also some plots. And this is all based on the Jupyter notebook. So I have it right here, so I can go here and actually open it to show it to you. Okay, so it's the Jupyter notebook. And yeah, so this is basically my Jupyter notebook. So I can go here and then execute it, and I can modify it. If there's a typo, I can just go here and edit it and stuff like that. And what's nice about writing stuff like that in the Jupyter notebook, like also the code and everything, is that I can, if I make an update, just rerun everything. So if I go there and make some changes to the code here, I could then go to the Jupyter notebook, and it's importing ML extend, or the function for ML extend here. So I can make an update and then rerun everything, restart kernel and run all cells, and then it will execute everything, and I can then simply double check if everything still works. If maybe my fix here maybe has broken some documentation, I can then see if some of the cells fail. So you can see it's currently executing this part and so forth. Of course, I have also unit tests, but that's way beyond scope for right now. I'm just trying to tell you how I use Jupyter notebooks and how I use Visual Studio Code and Python scripts. So I wish I could show you the homework right now, but it's not finalized yet. I will share it with you next week. And also right now, this week should be more about setting up your Python environment. So making sure you can run Jupyter Notebook or Jupyter Lab. And then next week I will go over NumPy. And for explaining NumPy, I will also use a Jupyter Notebook. And then I will explain how we do machine learning with scikit-learn, the machine learning library. And then we will also get back to the conceptual lectures like decision trees and talk about more machine learning algorithms. So this week was a little bit more technical. Next week we will talk about the tools that we will be using for machine learning, and then we will go back to concepts.